I would like to say hello and hello everyone and welcome to this webinar. We are so pleased to have you. I am Sophie from the CloudAMQP team and I will be your host this evening. The star of the show tonight will be our new message broker, LavinMQ, which we are very proud of. I will start by introducing our team and then they will introduce LavinMQ, what it is and how it works. After that, I will ask the panel a mix of questions to get the discussion started. We will wrap up this webinar by leaving space for you to ask any questions you might have about the technology or the project. Feel free to submit questions in the Q&A section down below, and we will answer them later on. So with me tonight, I have my dear colleagues from the LavinMQ core team. Let's have them say a few words about themselves. We can start with Carl.
Hi, and I'm Carl. I'm the CEO of It for Codes. I guess I initiated this project, and I guess I'm the main developer of LavinMQ. Yeah, thank you.
Victor?
Yes, hi, my name is Victor. I'm one of the developers at LavinMQ.
And then we have Jon.
Yes, hello, my name is Jon. I've been here at It for Codes almost 6.5 years. Lately, I've been working with Lavin, but before that, also another project, an MQTT broker. So it's messaging all the way.
Great. And then we have Christina.
Yes. Hello, my name is Christina, and I work as a developer and I guess project lead for LavinMQ. And I'm also going to give you a short walkthrough now of LavinMQ before we get into the panel discussion. So I'll cover what LavinMQ is, a little bit about how it handles messages, and then I'll wrap up with some highlights. And after this presentation, we'll dive into questions like Sophie said. So if there's anything that you're wondering about, take notes and we can discuss it afterwards. So to begin, what is LavinMQ? LavinMQ is our in-house developed message broker that we have been working on for a few years now here at 84 Codes. The basic idea of LavinMQ and message brokering in general is to facilitate the exchange of messages between applications or services. And this is good for many reasons, like not losing the messages that you're sending or letting services process messages at their current capacity instead of getting flooded. So here you see an image showing a typical message flow for LavinMQ. You have a producer, which could be your service or your application or whatever you're sending your messages from. The producer sends messages via an exchange, and the exchange is then responsible for routing the messages to different queues with the help of bindings and routing keys. So the bindings are the link between the exchange and the queue, and the routing key is an attribute that you can set on the actual message that's being sent into the exchange. The exchange looks at the routing key and figures out which queue it should send your message to. So this is a very simple example of the data flow of a message sent to LavinMQ, and it would look like this as the image portrays. A publisher publishes a message to the exchange. The exchange receives the message and routes it according to the routing key. Messages will then stay in this queue until the consumer handles them. And when the consumer is ready, it can subscribe to a queue and consume the message in its own time. Now, if you're familiar with CloudAMQP and RabbitMQ, this might all seem very familiar to you, which isn't too surprising given our experience working with hosting RabbitMQ as a service. The LavinMQ project, however, aims to engage that experience and build on and improve on the parts of RabbitMQ that we think can be streamlined. Okay, so moving on to look at how we actually store the messages that are sent into LavinMQ. We have something that we call the message store. which is basically just a series of files that we write to that we call segments. All the messages that you send and that are routed to a queue will be stored in that queue's message store. And when we store the messages, we always store them persistently on disk. And these messages are copied directly to the operating system's caching layer without the need for any system calls, making the writing to disk a lot faster than if we were to cache messages in RAM. So traditionally, solutions like RabbitMQ cache in RAM, probably due to the fact that they were built in a time where we don't have these fast SSD disks, and writing to disk was super expensive in terms of latency, which was definitely the way to go back then. But now that we have faster technology, we're taking the opportunity with LavinMQ to build something new and to speed up the process. Anyway, looking closer at the message store, we see here an image of how we would append and reference a message that's stored in a segment file in the message store. When a message has been routed by the exchange, it's both appended to the message store that you see here on the left, and it's written to the queue index that you see on the right. The queue index is just an in-memory array that stores segment numbers and segment positions and some additional metadata so that we can retrieve a message when the consumer wants to consume it. When a message later has been consumed, it's deleted from the message store when no queue index has a reference to its position in the message store left. So now that I've gone through some very quick LavinMQ basics, I'd like to finish with highlighting what LavinMQ does best. So LavinMQ is a super fast broker. We can benchmark throughput up to 700 messages per second, thanks to the priorities that we make when developing, such as looking back to what I mentioned earlier about realizing that we can use the operating system's cache and write to disk much quicker than handling messages in RAM. And we're also focused on resource efficiency, which really goes hand in hand with how we work with the performance. And thanks to the speed and the resource efficiency that LavinMQ has, it can handle this impressive load of data. And it actually handles scaling very well, even for being a single node broker. So putting a high priority on performance from the beginning of the project really makes an impact on the results that we're seeing today. And last but not least, LavinMQ really stands out in its simplicity. It's truly a lightweight broker in the sense that we have focused on simplifying configuration and trying to lower the threshold for you to get started with your projects. We work hard on keeping the documents updated and easy to understand, as well as releasing tutorials and code examples for different clients that you might be using. So that was my quick walkthrough on LavinMQ. Let's see if we can get deeper into it. Sophie, what questions do you have for us on the panel?
Thank you, Christina. I have a great one coming up right here. All of you are working with the hosting of RabbitMQ at CloudAMQP. Why did you see a need for another message broker?
When I started with LavinMQ, it was because we were feeling that we couldn't improve RabbitMQ fast enough. We saw so many limitations in it that with a very large and old code base would be difficult to overcome. There was also the opportunity that Crystal, the language, had come out and gives us really fast performance and very easy, fast for us to develop in. It's a very convenient language to develop in. And it was actually a customer bug that really bugged me, that we couldn't solve fast enough. And we had actually just developed a AMQP proxy for customers using PHP clients that can't hold long-lived connections. And I was starting thinking, why don't we just add a persistent layer to this AMQP proxy, because it already implemented the AMQP protocol. So we made a proof of concept, and it was very, very promising. Now, a couple of years later, we actually have a product, very solid product that we're very proud of. We think that RabbitMQ is super, it's really awesome, and is enabled us and customers to develop applications, their own applications with message queuing very efficiently. RabbitMQ supports many, many use cases, but we felt there was a opportunity to build something from scratch that might be better than just extending RabbitMQ, which you see today with almost or even more than 10 times the performance than RabbitMQ gives us. It allows us to support our customers even better because we are the core maintainers of the code. We can solve bugs very, very easily, and the whole application is, as Christina mentioned, greatly simplified. It's relatively very few lines of code in this broker.
Thank you, Carl. I also wonder, what would you say is the typical use case for LavinMQ compared to other message brokers?
So we try to copy the RabbitMQ behavior, but improve everything. So everywhere where you can put RabbitMQ, you can replace it with Lavin and get rid of some things like the delayed exchange plugin Rabbit, which we see a lot of trouble and problems with, and other dead lettering issues. So anywhere where you need a fast message broker, which is very efficient, resource efficient, actually. So yeah.
Oh, great. This new message broker is written in Crystal. Why was Crystal the perfect choice this time?
So a big thing with Crystal is that it uses the LLVM to compile code into native machine code, which is much more efficient to process. So this gives us a boost in performance, but it also helps us achieve a good balance between a high performing language and a language that has a really nice syntax. So Crystal's syntax is pretty similar to Ruby's. So it's a really intuitive language to read and to write, and it's really nice to work with. Another cool thing is that its standard library is also written entirely in Crystal. So it's easier for us as developers to dig into performance characteristics of different methods and functions and see how it will affect LavinMQ's performance. Yeah, so a couple of different reasons.
Cool. And at least I am very curious. What is in the pipeline for LavinMQ? Are there any new features to be looking out for?
Yeah, for sure. So first off, I'd just like to say that we don't have like a set release schedule or anything, but we work pretty much agile and we'll release whenever we're done with functionality. With that said, the things that we're working on right now and over the coming weeks or months is hot standby replication, which is a way to increase your redundancy if you're scared of any nodes going down or something like that. We're also working on stream queues and multi-threading support. And besides that, we're obviously also working on any bug fixes or just smaller continuous improvements.
Oh, cool. LavinMQ is a single node broker. How would you tackle a reboot of the system and avoid downtime?
So in our experience, the cloud VMs nowadays, they're extremely stable. So we run thousands upon thousands of VMs in the different clouds, in AWS, Google, Azure. And downtime from hardware failures, from disk failures and such is very, very rare. We see a machine reboot about once per third year over a whole fleet. So generally, I'm not afraid of downtime from the VMs in the cloud. That was, of course, different when if you're self-hosting, you have your own hardware, etc. The disks in AWS, the EBS, Elastic Block Storage, is replicated 3 times. We've never seen, and we have petabytes of data in the cloud, and we have never lost a byte. It's extremely reliable. That said, there are cases where you want to minimize downtime, of course, and that's why we're developing this replication system as a first step. It mimics Postgres behavior a lot. So basically, you have the leader instance, and then you have a follower, and then that gets the real-time changes to the data store and updates the data store in real time. And it also replicates or mimics the behavior of Redis replication, for instance, for people that are familiar with that. We might, in a more distant future, include something like a raft protocol, something like that Kafka does, or other databases. But for now, we think this is covers 99% of all use cases with a hot standby replica. And then, of course, you can add the external leaders election system like Consul or Zookeeper that does the failover, the leader election on the failover.
Thank you, Carl. That is all the questions I had for today. Great answers, team. Now let's see if there are any questions from the audience. And as I said before, feel free to submit a question in the Q&A down below. Oh, here's one. Or actually, we have 2. Let's start with this one. If I want to help out developing LavinMQ, what is the best way to go?
I would say fork the repository, make a pull request, and we will take a look at it and discuss if we want to include it in the project.
Cool, thank you, Christina. We also have another question here. Is it possible to consume a message multiple times, like in Kafka, where you keep the messages in the queue?
That feature is coming very, very soon. We call it stream queues, and it's not there right now, but in the next major release, it will be included for sure.
Great. Here's another one. Do you have support for MQTT?
No, not natively in Lavin, and probably not in the near future, but we're working on a MQTT proxy, which you can put in front of an MQP server to handle, which will terminate the MQTT connection and then actually use the MQP server as a more like a backend as the persistent storage, even though it will be even a storage in this MQTT broker itself. But so we will probably be able to provide a solution for hosting this as well in CloudAMQP in the future.
Thank you, Jon. And the last question is, are there any support for plugins?
No, there's not, and probably won't be, but instead we try to include, build everything that we think that is actually needed into the broker. So we maintain thousands upon thousands of RabbitMQ servers, and we know what plugins are popular or not, and we try to incorporate them natively into the LavinMQ code base.
I think that that's all the questions we have, unless there's no more questions from the audience. So I think I'll give it 10 seconds to see if anyone has any more questions. Otherwise, we're going to wrap this. Oh, here's another one. Are any main features compared to RabbitMQ missing?
Yeah, so we don't have the new kind of queue types, the quorum queues, and stream queues, as I was just mentioning, but that's coming very, very soon. And what else is missing? Yeah, clustering in general. Replication is very, very near. But otherwise, I think we're covering, of course, the whole AMQP protocol. We have the UI and the HTTP protocol. And it's very little that's missing from RabbitMQ.
Thank you. We have another question. Performance aside, is there any other reasons to migrate from MQTT to LavinMQ?
Yeah, I'd say that it depends on what your needs are. MQTT as a protocol, I mean, it's a lightweight protocol, but it also kind of strange protocol with feature that isn't, with it quality of service features, which isn't really true, and a lot of things. I don't know, and I would say it depends on what MQTT broker you're moving from, and if you're going to move to LavinMQ. But I think it's nice to have the AMQP as a backend in the long term, maybe for if you have a lot of MQTT clients in an IoT network, something, and then they are communicating to your backend. I think it's nice to have a MQP server behind the in between to extend your possibilities. Actually, anyone maybe have something else to add?
Let's see. We have another question here. Do you have any plans on making incoming and addressed messages more visible in the web interface? Better visual, that's hard to pronounce, better visualization of visibility of what's happening in the queue at the moment?
Not really. But we're open to suggestions of how this could be done better. Please open a discussion in the GitHub repository. I'm not really sure what you mean, Camelia, how this could be visualized. But if you can mock something or just explain it in text a little bit more detailed, we can definitely consider it. We think that visualization is really key and important, and something that RabbitMQ, for instance, lags a little bit in. Their management UI is a source or something that has made RabbitMQ even more popular, because you can actually visualize. You can see what queues you have, what throughput there is in them, and you can look at individual messages, or at least the head of each queue. But that it lacks a little bit. And then, of course, Kafka doesn't have any UI. It has the CLI tools only. There are third-party UI tools, of course, that you can buy or try to install open source, etc. But UI is very, very important, and so that you actually can visualize and see what's going on in your system. So it's definitely a key part for LavinMQ, and today I think is already a big improvement over, say, Rabbit's UI, because it's super fast, super snappy, works offline, and it's yeah, I really like the UI, how fast it is.
Thank you, Carl. Do we have any more questions? No, it doesn't appear to be any more questions. I would just want to say thank you all for contributing with good questions. Also, we would like to take the opportunity to thank you all for tuning in on today's session. Hopefully you have enjoyed listening to the LavinMQ team and are excited as we are about this new technology. If you have further questions or just want to chat, join our Slack community or email us at contact@lavinmq.com and we can continue the conversation. Thanks again and have a great evening, everyone. Bye.